Today I want to do some examples with the exponent rules to make you guys feel a little more comfortable. So first point I want to mention, point 0, is to practice your powers. So that means doing 2 to the first, 2 to the second, all the way up to 2 to the 10th and beyond. So 2, 4, 8, 16, 32, 64, 128, so forth. You could do this with 3. You can do this with 4, 5, just to get familiar. There's no need in memorizing these, but just keep doing a few of these so if you see them, you're not freaking out. All right, so the first problem I want to do is this one. So this is 8 to the negative 2/3 power. How do we calculate this? We're going to split this up. So here I've written a power to a power to a power, which looks like this rule. So why do we do that? If you notice, there's 3 things going on here. There's a minus or a negative, a 2, and a 3. Now we could also have written this way. This rule says multiply the powers. So these 3 numbers multiply to negative 2/3, as do these 3. By the way, you could split it into other numbers such as 4 and a 6. As long as these multiply to this, you're fine. Why is this order better than this order? Because in this order, the 1/3 power is the 3rd root. In this order, you're squaring the 8, which means you're first increasing your numbers and then decreasing them. We're lazy and stupid, so we want to first decrease our numbers and then increase our numbers because it's easier. So we don't want to work with 64. So what's 8 to the 1/3 power, or the 3rd root of 8? This is which number times itself 3 times gets you 8. So that would be 2. 2 times 2 times 2 is 8. That's what this 1/3 power or 3rd root means. Then we're going to do 2 squared, so that's 4. And we're going to do 4 to the minus 1st power. So that just means flip it, or take the reciprocal. So it's 1/4. In this example, we would have gotten the same thing. We would have gotten 64, take the cube root of 64, which is 4, and then flip the 4. Again, gets you this, but it's easier to work with 2 than with 64. So let's try this next example with 16. So again, there's 3 things going on. There's the negative, the 3, and the 4. So the 4 means take the 4th root, not divided by 4, but which number times itself 4 times gets you 16. So that's 2. So that gets you 2. Then we go to 3, 2 cubed, that's 8. And 8 to the minus 1st is 1/8. So if that was a little too fast, try applying each of these operations by themselves in this order. So that's what we did. This was 2, that was 8, that's 1/8. All right, next let's try this problem. Now at this point, a lot of you guys are probably trying to do the 3 first because that shrinks your number. In this case, I would encourage you to do it slightly differently. I would do the -1 first, and then the 1/3 power, and then the 4. The reason I would do this first is that this flips the number. So since we have a fraction, if you flip this fraction, you will undo the fraction, so you only have to work with a single number of 27. Doing it any way will work, it's just a matter of what's easier. So this gets you 27, because 1/27th reversed, flipped upside down, is just 27. 27 to the 1/3 power, or the cube root of 27, is 3. And what's 3 to the 4th? That's 3 times 3, which is 9. So it was basically 9 times 9. There's 4 3s altogether, so that's 81. All right, so I encourage you to pick some other numbers such as 125 or nice powers and try some of these fractional powers on your own. Alright, let's take a look at number 3. So this says the square root of 4 times the cube root of 4 times 4 to the 1/6 power. There's one main moral to this story. You could find the square root of 4 as 2, but the point here is to say that you could see these problems expressed as roots, powers, or fractional powers in different formats. So let's convert everything to fractional exponents. So instead of using the square root of 4, the square root is a half power, so we're going to rewrite it this way. The cube root is a 1/3 power, and 1/6 stays 1/6. So now what is this? This is this rule. So we have the same bases and different exponents, or any exponents. So we're going to end up adding a half plus a third plus a sixth. So this becomes 3/6, 2/6, and 1/6 to give them a common denominator. So that would be 3 plus 2 plus 1, so that's 6/6, or 4 to the first, which is just 4. So the point is, this looked really ugly, but after we've converted it to fractional powers, they all combined and gave us something nice. So don't automatically freak out if it looks like this. Alright, the last problem is not meant to be super difficult. This is just saying which number times itself 10 times gets you 1024, or what's the 10th root of 1024. Now, if you practice your powers, or if you decide to, problems such as this become very easy. You would know right away the answer is 2, because you would have 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. That's 10 2s. So now let's say you want to do something like the 9/10 power. You don't have to redo this problem. You already know the 10th root is 2, and the 9th power means you're now using 9 2s. So rather than stepping forward 9 times, we can just go backwards once from this number and get 512. So we're dividing this by 2 rather than going down and then back up. But again, you can only do this if you're practicing your powers and you're familiar with what you have a feel for what happens here. Alright, stay tuned for the following videos where we go into some more intermediate problems and focus on one problem per video.